Okay, this is basically a schematic for a triode, any old standard triode, half of a 12AX7, or any of various tubes. I'm just going to use this to show you the basic parts of the schematic diagram for a tube. This triangle area with two leads coming out is always the heater or filament. This is what you hook to 6 volts, 12 volts, whatever the tube calls for, and it gets hot. That's what makes the tube glow. This upside down parenthesis type deal with the lead on it is the cathode. This part of the tube is coated with a coating that will help it freely release electrons. The electrons always flow from the cathode out to the plate. This is the plate, this upside down T. Some tubes, this will be a cap on the top of the tube where the wire connects to. Most tubes, it's just one of the pins on the bottom as a normal pin, normal connection to the tube. The plate is always where the electrons flow to. If you have a tube that is incorrectly biased, something's wrong with the amplifier. The plate is usually the outermost part. It's black in the tube, and it will glow red, sometimes just slightly red. Sometimes it'll glow cherry red. If you have a tube amplifier that the metal part of the tube is glowing cherry red, turn it off. You risk serious damage to the transformers, which are expensive to replace, and you could have any one of several other problems with the amplifier. And 9 times out of 10, it will not sound right if the tube is glowing cherry red. There's too much current flowing, so turn it off. That's just some advice. Get it serviced. Usually it's a capacitor or something that needs looking into, possibly a resistor. It's not serious. If you continue to run it, you risk damaging something that's very expensive. This part in the middle with the dashed line, that's the grid. All triodes have a grid, as far as I know. Those are the 3 parts. You don't count the heater usually. So a triode is 1, 2, 3 parts. A cathode, a grid, and a plate. Current will flow from the cathode to the plate. These are just some other tubes. This one down here is the basic triode that I just showed you in the previous diagram. This is a basic diode. There's a filament and a plate. There is no grid, there is no control. The grid is what controls it. It's like the base on a transistor. And we'll get into that in either farther in this video or in the next section. This is also what you would call a directly heated cathode. Some of the older tubes that I showed you, like the 01A and those older style 4 or 5 pin tubes, do not have a separate cathode lead like the rectifier. Therefore, they are usually run with DC voltage on the heater, the filament. In other words, you will get a lot of hum because your signal is applied to one of these leads as well, the electronic circuitry for the signal in a triode that is directly heated. But diodes aren't in the signal path in a radio or amplifier. They just rectify the power to DC. So the directly heated cathode is fine. There's no problems with that. This is the schematic diagram for a 5U4, a very common rectifier, especially in tube amplifiers. It can be used as a full wave rectifier. There are 2 plates inside and 1 filament. This is an OD3 gaseous regulator. They're a little bit different. There's a gas inside, and I believe that each style tube, the different number gaseous regulator, have different gases in them that react to different voltages. And I believe they work like a Zener diode. If the voltage gets too high, the gas will allow the electrons to conduct across this joint here. Now I don't know what you would call this, if this would be a cathode or what. This is a plate and this is a heater. And they will glow. Some of them are purplish, some of them are a slight blue. They'll glow as they're working. That's completely normal. Some power amplifier tubes glow as well. When we get into the section on amplifiers, I have a Heathkit AA50 stereo amplifier that has very nice purple glow to the power tubes, and I'll probably will show you guys that. So those are the basic parts of the tube as far as the diagram goes. Okay, it was my mistake. That was actually a 5U4 rectifier tube. I do have a 6L6 that I will sacrifice and show you the inner workings of that. But basically these are the parts. This is the socket end of the tube that would plug into the base. These are the filaments. There are actually two filaments in the 5U4 that are connected in series. The 5 signifies 5 volts for the heater or the filament. I don't know if you can see it, but this is a whitish colored coating on this flat wire. That's what helps release the electrons, and it's also basically a directly heated cathode. This is a piece of mica insulator that holds the parts of the tube together, and this part is actually the plates. These two plates here is this black part of the tube. It's made out of metal, and it's connected in the circuit by the two leads coming off here in the schematic. So you basically have this thin wire run up through this plate and back down and out the bottom of this hole in the plate. It doesn't touch the plate. There's airspace all the way around. Now when you energize the tube, this gets hot. This wire will get hot and glow, and once the tube starts conducting, current will flow from the cathode to the plate, and only one way, because it can't flow from the plate back to the cathode because the plate itself isn't hot, it isn't heated, only indirectly off from the heat from the filament. But there's no coating on the inside of this. This is just metal. So there's nothing that will release the electrons from this backwards. Therefore they only conduct in one direction. Hence it's a diode. It only allows electric to pass in one direction, from the filament or cathode to the plates.